and welcome to Big Data Europe 2022, day 2, also for me. My name is Floor Drees and I'm a staff developer advocate at Ivan.io. I'll be your host for the cloud and streaming track today. I'd love to encourage you to ask questions, take part, and be curious. And we're starting today with Roberto Freato, who's a CTO at Taylor, which is a leading, and I quote, leading company in the Amazon and e-marketplace services for brands.
In Italy.
Like commercial ends there. Um, and he will talk about implementing a serverless data analytics strategy with Microsoft Azure. Roberto is a fellow Microsoft MVP since 2010, which is a really decent milestone. So I want to say, whenever you're ready, Rob, take us away.
Okay, thanks so much for the introduction. Yeah, and thanks for joining this session. What I'm going to show you today, I used to be a developer and for my entire life, and so the session is how a developer like me approach the big data with Azure, and how we solved some issues and how we faced some problems. Okay, during the trip, essentially. So, to give you some context, I work in this company where we are like an agency with some real big data services for our customers. So we made intelligence project. Okay, well, I mean, with intelligent project, we analyzed a huge amount of data and we provide some real nice insights to them. Okay, and to do that, we as like the developers, okay, the software innovation team, we need to provide data set to internal parties of the company. Okay, so this session is about this travel, is about this path. We started with from scratch, okay, like 3 years ago, 4 years ago, something like that, and we had the relational databases. So we just had like a few instances of MySQL, and then with some tools like Data Studio, Tableau, pointing on them, okay, to build our insights. So we discovered that this kind of approach didn't scale, okay, so we tried to consolidate them, all the database, to a single one, okay, we in Azure, okay, so SQL database, the SQL Server offer in a platform as a service fashion, okay. After that, we achieved good result in terms of scalability and a single source of truth for our data, okay. But the next big thing is to handle data that should change its schema frequently. Okay, think about you integrate an API from a third party, okay, and in this API we receive a JSON object that is composed by like 10 fields, okay. After a week, a month, a day, a period, okay, these fields are 12 or even 20 or 30, okay, or even they change, okay. It's not so common that a contract has been broken with an API, but it can happen. Okay, in that case, we tried to handle JSON directly into SQL. Okay, without the need to change. Frequently the schema of the tables. Instead, we put directly JSON to SQL, and it worked. It was real a good solution because SQL databases scale so good with this kind of approach. But then we faced another issue: the storage size and the data movement pitfalls that we had with this huge amount of data inside SQL, inside field, JSON field. Okay, and we approached the file storage. Okay, that initially, we call it the data lake, but initially it wasn't really a data lake. It was just a file storage because we hadn't so much um, skills, okay, around it. So we just organized those JSON objects in files and folders, okay, and then when we made some experience, then we scaled this to a real data lake, okay, with partitioning, with some concept that we are going to discuss later, okay. After that, we are investigating yet still with some many variations around it. Okay, so we are trying to partition the data lake manually, automatically through Spark, with some other value added services in the middle, okay, to go to an approach for our data platform that is called even a data lakehouse, when we can have a data warehouse, a relational database, and a data lake that are in a way connected together to build our data platform. Okay, so those are some words of this session. So probably they are quite familiar for you. So the data movement is a process when we move and we move data from a source to some things. Okay, the landing storage is an important concept that should be familiar with when you ingest your data. Okay, the first point of contact of your data should be the nearest the nearest as possible as your source. Okay, what I mean is do not try to handle some complex manipulation logic or some uh, logic at all on your incoming data, because something may happen and you can even have issues with your logic. So the very first things to do is to take your incoming data and put them into your landing storage. Okay, this process is called also sourcing. Okay, the process where I ingest my data sets into the first landing storage possible. Spark is a technology that you probably know is an open source technology to run code on clusters. And that code often is data movement and data engineering code. Databricks is platform, okay, a platform that implements Spark, implements Notebook, provides us good value-added services. We are not investigating Databricks in this session. We're just taking a look at signups. And what else? So cloud big data is probably something that is a real commodity right now in terms of definition, I mean. Okay, so let's go ahead with the discussion of the data sets we are working on. Okay, those are not real in terms they are surrogated by me, but they resembles real reports that are coming from the APIs that you are working with. Okay, so I just manipulated it to simplify them for the demonstration, but they resemble real APIs. So we have three types of reports. So as you can see, we have the clicks report with custom clicks, conversion with sellout in conversion, impression with the count, and so on. Okay, and actually the purpose of the session is to handle them, to ingest them, to manipulate them, to consolidate them, and provide a result, what we can call a gold data set for the consumer. What is a gold data set? In the Databricks terminology, we can have three layers of data sets: the bronze layer, the silver layer, and the gold layer. Okay, the bronze layer is the layer really near to the source. Okay, so we can even call it source aligned. Okay, the silver layer is still near to the source, but it's curated. So in a sense is cleaned, is maybe strong typed, is filtered, something like that. And the gold layer is the data set that is more consumer aligned. So what I mean can be an aggregate, can be a result of multiple joins, aggregations, enrichments, and so on. So let's take a look at the ingestion that we are performing with a console application, just to leave it to you through GitHub. Okay, so let's go here. Okay, in this service, we emulated this like this ingestion phase from an API with this mock. Okay, so we are uh, generating thousands of events, okay, in a randomic way. Okay, and we are writing them to a storage account. So to do that, let's go ahead to Azure. Let's take the connection details of the storage account here. This is the connection string, and let's give it to the code. Let's write all the stuff into a folder that's called Big Data Europe, and that's all. And let's go ahead with the debugging session. In the meantime, I will comment the code. So let's just see if it's working. I'm expecting that it's generating reports for some days and putting them into the storage. So, okay, let's wait a second. It's okay. So what's happening under the hood? It's taking those reports, okay, those objects, and in a way, we upload them in a batch style. What I mean with batch style, without any structure, without any partition, without any real logic. Okay, we're just taking the JSON, give them an ID, GeoID, and putting them in a single folder. Okay, this can be a good approach, and remind that in big data, 99% of the cases you're working with messages, with queues, with events, with something else like Kafka, like a service bus, like a Rabbit, like a Pulsar instance, something that can handle messages. So why I'm telling you this? Because when you upload your data set, your small piece of data into a storage account, into a landing storage, after that, you should probably put a message in a queue to say to the third party, yeah, we have this new piece of data, so process it, okay? Push it to the next layer, push it to the right hand point. Okay, so that's why this can be a good approach to just to put all the data into a single folder. It's not real. It's not a problem. Okay, but we also want to directly partition the data lake in a way that can be useful for their manipulation of the data itself. Okay, so in this case, we are partitioning the data set with the report type, the year, the month, and the day. Okay, and after that, the report is just a file named report.json. And with this notation that is standard in the Hadoop, Big Data, Spark ecosystem, we are pushing some important part of the semantic of the data set itself, like the year, the type, into the folder structure. Why it's important? Because with this notation, we can then reuse this kind of variables in the data movement and the data engineering part. Okay. We also let's go to the step 4 just a second. We do the same thing, the same exact thing of the step 2, but in this case we write a Parquet file. So we are converting the JSON into a Parquet file. This is something that should be avoided in the sourcing part often, because as I told you just a few minutes ago, in the sourcing part, you should write your incoming data as soon as possible without any kind of logic that can fail. Okay, but in this case, in this demonstration, I want to show you that we can convert the JSON into a Parquet, okay, and upload it as a Parquet. What is the Parquet format? The Parquet format is a column store format and strong type format. So in that case, we are writing something with a schema, a fixed schema, and with a good compression, because it's storage in a column store format. Okay. The last way I implemented this ingestion part is with the append mode. Okay, this can be really useful because if you don't want too many files in your data lake, you can even use, in this case, a blob storage technology that's the append block API, okay, to append some content in at the end of an existing file, okay. This can work just with text files, okay, CSVs, JSON. CSV is just a collection of lines, so it's okay. A JSON can also be represented by lines of individual JSON object. This is called JSON lines, so it's a standard, okay, in a way, and it's a good approach to avoid this huge increase of files into your data lake. Keep in mind that if you have a message driven architecture with the capability to reprocess the same message multiple times, so in a at least once approach, you can write the same object to the same blob multiple times. So when you have individual files, you can override it, but in the case you have append files, you can append multiple times the same object. So it can result in a duplicate issue. So keep in mind this with the append strategy. So in the meantime, we have generated a month of data, okay, with a few days more. We can stop it. It's okay. And we can go to see in Synapse the result of this demonstration. So let's go to the reports folder. Here inside, I'm expecting the BDA folder, and we have the batch files. Okay, so for each one, like 1 MB approximately, we have these lines of events. Okay, and we also have the append ones. So in this case, for a given year, we have just one file. Okay, that is not huge, but of course bigger than the individuals ones. And this is the partitioned way when we have the type, the year, the month, the day, and two files. One is JSON, one is Parquet. Okay, Parquet is binary, so we cannot see it with a notepad. Okay, but and you can see, you can notice the compression, okay, but we can use a technology that's called Synapse serverless pool, SQL pool, that is not a real database, okay, but it's like a bridge, an engine that stands between the data lake and the relational world. So with this kind of query, and we can even use it here in SSMS, so it's not something that is just related to the Synapse. We can have a row-based result, okay, a tabular result, a SQL-based result for something that is represented in a data lake as files, okay. So this is this file, this Parquet file, but we can also say do not keep just this one file, okay, but we can also take some wildcards here, and this will explode all the wildcards to look into the specific folder. We can even say, let's keep the file path 1, 2, and 3, that is 3 segments I'm going to explode, and use them like date. Okay, we can say, just a moment, okay. We can say concat, yes, and then convert as date. And this creates a surrogated column that we can even use to filter our query. And what's under the hood, the expression, the filtered expression will push down the operators to the engine that will scan just the folders we need to take the results. So it's a real good practice to explore the data lake and even to provide the results to Power BI onto your endpoints. Okay, good. So this is just the starting point in signups. I just want to start the Spark pool for after because it takes like 2 minutes. So I want to start it. Do not look into this, just operation for me. Okay, good. And let's go back to our presentation. So now we have some data inside the storage account, and we want to consolidate it in a few ways. Okay, the first one is the data copy approach that we are going to do right now, and after that we will see data flows and Spark Pool. Why I'm putting Synapse Serverless and Synapse Dedicated like consolidation alternatives? It's quite tricky and it sounds like more a workaround, but with the Synapse Serverless, so the approach that you just look at to with the select star from the data lake, etc., we can also say to a target. So we can like write a SQL query like select into, okay, not with the into statement, but we can write something like select the stuff from the data lake against the destination in the data lake itself. So can be used as a consolidation tool, but it's not really my favorite one. And the Synapse Dedicated is the data warehouse. So we can do the same thing of serverless plus many other features with the dedicated pool. But let's start with the data copy approach. So we can create a pipeline with a data copy flow. Okay, let's collapse some stuff here. Good. And let's connect to a Gen2 storage that's just the data lake with which is the difference between blob storage and data lake storage Gen2. It's the same technology, but represented by two different endpoints to go against it. So the blob storage endpoint type is just HTTPS. The lake data lake storage Gen2 is with a protocol that is HDFS based. So it's better for big data processing. Okay. I want to go to a Parquet data source with the storage account. The path, the initial path is reports. And after that, I want to take all the stuff in BDE partitioned slash type clicks. Let's start with type clicks and star.parquet. So let's preview the data. Okay, it's good. And I'm expecting also to have the columns of the parameters in the folders. So what I mean here, let's go there. Yes, the same. Okay. And as you remind in the partition at this folder, we have year, month, and date. I want to push these variables in the dataset itself as columns. Okay. To do this, I tell the engine discover the partition. Okay. And with this discover the partition now, I also have the partition values here. Good. Let's consolidate all these reports into a single Parquet file. So let's replicate this kind of configuration in the real world. You will reuse these data sets, okay, with different parameters, but to be faster in the demonstration, I will create new one with Parquet 1, Parquet 2, Parquet 3, and so on. Okay, it's not real best practice. Okay, now I'm telling the engine to merge all the files you find in the source to this single sync, and the file name should be bd slash results slash like type equals clicks dot parquet. Okay, something like that. While I'm debugging this session, what happens now that a pool will take this activity, will run it. A pool that is already like created is not something are under control. It's serverless, and we're paying just for the minutes it runs. We can see it in action here, okay, with some nice insights. Okay, what's running under the hood? That's here, it is creating this folder and this file. So probably it's finished. Yes. Okay. But this process, that's quite simple. Okay. So with this process, we just consolidated like, I don't know, 30 reports. How many? Let's see it here. 35 reports into a single one with a nice further compression. So the single parquet are compressed by, if you merge them, they are so more compressed. Okay. So we produce a single destination file, but just for the type clicks. Okay. Let's try to do this in a more general way. So the logic can be for every report type that you find here in this folder. So try to infer it dynamically. Okay, produce a single file in the destination folder. Okay, to do this, I use the action get metadata. I will point to the same exact Parquet store. Oh, yeah. And I will just say, hey, discover what's in the partitioned part. Okay, good. Let's go here. What I want to discover, the child items of this path. So I want the child items. Let's debug just this one, putting a breakpoint here. And let's see the result. It's a matter of seconds, I hope. I hope. I still hoping. Okay. And I have this listing. Okay. This get metadata is dataset agnostic. So you can use it with SQL. You can use it with any dataset. And in case you are joining it with a storage account, it produces a listing of the folders. Good. So now the approach can be, we have the result here that is an array of child items. I can say, hey, for each, and the for each is on, that's okay. The for each is on the child items. Okay, so the output of the previous activity in the items, child items. As you saw it, the child items is a collection of name type values. I need the name one. Okay. So I take this copy data and I put it into the for each loop. And now I can generalize this part, taking this one from the loop itself. Okay, so I say use a dynamic content with the concatenation of this string with what? With the current item. But item is the key value item, name and type. So I just need the name part. The source is okay. The sync is not here, but the file name is specified inside the dataset. So inside the dataset, we don't have any context of the outer loop. Okay, so we need a trick. And the trick is to create a parameter that can call the file name. Okay, or just type as you want. Okay, use it here. So here we can uncut type and the point parquet. And now that this data set is parametric with a parameter, let's go up and we see this parameter to be pushed by this point that has the current item context. We can now go to the pipeline and debug it. Okay. It's not, doesn't like this name. That's okay. Now, after the get metadata activity, the for each will spin 3 parallel data copy activities. So keep in mind that if you achieve parallelization, of course, your results are faster, but you are consuming much and more resources than a single instance activity. Okay, so in this case, for each copy activities, we are using this. Let's just wait a few seconds more. Okay, we used like 4 integration units for all the 3 jobs. What is an integration unit? Is the artifact that is built. Okay, so that has a cost. Okay. Of course, the result is quite fast. So here in the results folder, we have all these 3 parquet, and that's all. So we consolidated the files, multiple files in a single one. With the pro of this approach is that you just saw it is really fast, is really intuitive, but it works just as an appender. So if one parquet of your source dataset is different compared to the previous one, because starting from March, you have a field more, okay? This won't work anymore, because when it detects a drift in the schema, it will fail at runtime. Why? Because it's just an appender. So it's just something that works with the same exact structure of Parquet files. If you append JSON or CSV, of course it can work, but they are not strong typed in that case. So you need to perform the typing after. So now we are going to look at the data flows. That is like Spark without the need to write code. Okay. So let's go with the data flow. Let's create a new one. The UI changed. I put the same exact parquet, but in this case, I can start with the 3 results that we just generated. So let's take reports, reports, then bd results slash dot parquet. Okay. Let's try to import the schema. In this case, the engine, the debug engine, this one is going through the folders to take the files and infer the schema. Not really infer, because it's Parquet, so it's strong type. It's actually getting the schema for all the files that it found. First 10 files, 100 files. So it's not really scanning all the files if you have million of files, okay? But it worked. And after that, I want just select just a few columns, the country and the cost, okay, to provide an aggregation. So my result should be for all the report types, different types. I just want to say an insight that is country and total cost. Okay, it doesn't matter the type of the report, because I want to know how much I spend it with these campaigns. So country and cost, no clicks, no year, no month, no day, no sellout, no conversion, no epoch. Why there's the country code? Because in one of the 3 types, country is not named country, but country code. So now with this data flow, we can even say transform the country code field into country. Okay. And let's strip out campaign ID, creativity, impression count, and that's all. After that, we can perform an aggregation. So we can group by country and aggregate the cost column with this really simple expression. Let's take a preview. if it takes seconds. Otherwise, we will see directly the result. Okay. In the meantime, this aggregation, okay, it's not working, but it's okay. Sometimes this preview is not working. No problems. I want to write this in a SQL table. So my goal dataset is not on the data lake because there are just few lines, one for a specific country, and I want to write it to a SQL database. So SQL here. Let's create a new connection with the server. The database should be demos. The authentication should be the managed identity. Let's see it. It's working or not. I hope yes. Yes, good. And I want to use the DBO schema. The table can be BDA. And for each execution, I want to recreate the table. Why? Because the single source of truth is not here. This is just a result of an aggregation. So it's okay for me to drop and create every time the table that will contain just few lines. Good. So now let's debug it. And I'm expecting in the relational database here to have a new table called dbo.bde. Okay. So we have it. And this is the result. Okay, and we achieve this transformation thanks to the data flow that is more powerful and can handle also the different types of data set. It handles it seamlessly without any kind of issue. Good. This is the second way for to consolidate data. The pro is that is still UI based, but if you need to customize your logic, can be harder, of course, as every UI based tools. Okay, so now we are going to take a quick look to Spark Pool and Spark Tables. Okay. So the Spark Pool is something that you should create before working, and is based on machines, but it's pausing itself when it's not used. So it's not really serverless, but it's like in a consumption based model. Okay. What I want to do, I want to take this as a Spark table. I use this notebook that has attached the already started Spark pool. And now I want to create a table that is called BDE. What is doing this code is reading this parquet. It's not important that is now reading a parquet. The load part can be against parquet JSON, a huge amount of files, okay? So let's try to imagine that in this line 2, we have the logic of getting the file. So not just a single parquet. It doesn't make sense just to write a single parquet into a destination Spark table. What is a Spark table? A Spark table is actually a collection of parquet, but not managed by us directly. So what happened under the hood, that Synapse created this folder with this parquet, and it will continue to manage it without our intervention. So what I mean is that if I create another cell with insert into this table, values, or the first value, also the external tables that we are creating through Spark are also available here in the Synapse serverless pool. Okay, so now I want to insert a row here. So there's just timestamp, country, some strings, cost and clicks. Good. So current timestamp. Good. There's country, some strings, the cost, the metric, a date. Okay. Oh, something is wrong. Oh, okay. Good. So we can now use SQL, Spark SQL, to go against this table. Under the hood, Synapse and Spark will create new files, okay, but the result is that we can have country equals to equals to 100, that we have even the row here. What we cannot do with Spark tables, with plain Spark tables, we cannot update. So let's update tables, set cost 100 where country. Why? Because default Spark tables are not updatable. Okay. Let's think about Parquets as immutable files. Okay. They are not technically speaking, but they are in 99% of the cases. So if we want a destination table that can be updated, we should write the dataset, the destination table, in a format that is called delta. The delta table, EDA delta, is an open source format which handle the same exact Parquets, but with like a transaction log that um, describes all the operations against, all the writing operation against the table to provide a layer of transactionability, consistency, and even updatability to the data source. In this case, we can update the BDE delta, but just before, let's look into this to see, okay, if it's working. Okay, so let's get start country. So different values for cost and clicks, and the rows are like 28,000. So now let's update it here. Under the hood, we have another table, and we will have different parquets, but the difference now is that we have this transaction log that describes this operation, and it's used also in the query part to know which rows I'm going to return, the one in that parquet or the ones in that other parquet. So, okay, it worked, and now we have the same exact rows I'm expecting, but with a different cost. Under the hood, the rows are like duplicated because parquets are immutable. But with the delta log, the reader can differentiate them and just return the one that should be returned. Okay. So with this last sample, we just give you a tip on what should be the next big thing in terms of big data. It's not really the next big thing. It's just widely used. Okay, but if you want a destination, something that is big data, and even as some ACID support, so transaction atomicity, etc., you should take in consideration the delta format. Keep in mind some takeaways. So the stability of source, remind that your data should be versioned as your code, as your APIs, as everything. So data should be versioned as well. Okay, why? Because from version 1 to version 2 you can have a different field in terms of semantics, or an additional field that can injure your pipeline. Okay. Also, keep in mind that if you write a delta table that is updatable by design, you should go into the pitfall that you may have two different source of truth. The one is the source, and the second one is the destination. It's better to think about the destination as just read-only data set. Okay, so you can take the single source of truth in the source, but it may happen you will have also destination that are updatable. In case you don't need to update your data because you just write big data that is immutable itself, you are lucky. So many of this technology can be avoided to just append stuff in a way that doesn't need any updatability. So that's all for the session. I thank you very much for being here, and I'm here for the question for a few minutes and even later uh, in other channels, maybe. Okay, Fleur.
Awesome. Thank you, Rob. That was a great presentation. I have a couple of questions, but I saw that the audience also has questions. So let's
Okay,
let's get theirs answered first, and maybe we can have a chat later on. Um, First of all of them, thank you for your presentation. So the
thank you
one
to you.
question is, I also work with Azure. Is what someone says. Can you describe the difference between Synapse approach and Data Factory plus Azure SQL?
Okay, yeah. Actually, Synapse is as was born as a collection of existing tools. So, first of all, ADF, Azure Data Factory, is 99% present inside Synapse. So, what I used in Synapse is actually Azure Data Factory. So my suggestion is, if you have not dependency of the existing ADF instances, use Synapse at first. Okay, from the beginning. The difference between an ADF plus SQL is that when you use SQL instead of ADS or Synapse as your integration engines,
Hmm.
SQL has some pitfalls in terms of scalability. What I mean is that even with hyperscale, that is the last tier of SQL database that can handle even 100 terabytes of data, you can have just not a limited, because limited is everywhere, but a very limited multiple and concurrent connection and IOPS, so IO per second, compared to the storage. So if you need like 10 parallel queries on your SQL database with a huge data set for each query, you will probably hit a cap into the SQL, the relational part, and you want against the storage account, so the Gen 2 data lake. So that's why actually we are using a data lake, not because it's more because it has more features, but because it's more scalable. Totally.
Awesome. Thank you.
Hope
Um,
I replied the question.
I hope so too, but I guess we'll see in the chat if there is any follow-up questions that regarding that. Let me see. There is another question. Could you share some best practices about bronze, silver, gold layers of data? Um, and then
Sure.
as a follow-up sentence was, it may be just different virtual folders in Azure Data Lake, or better separated data into several resources.
Okay, it's a good question. We are working on it in the last 6 months. Okay, to achieve the perfect result. What I'm thinking about is there isn't a perfect result, and the opinion we are making in this few months.
Hmm.
But and this question deserves a dedicated, not really a session, but probably a day or a week to discuss about it. But think about this: bronze should be really near to the source.
Closest.
So if you have a source that's a JSON with the three fields, just keep the JSON and don't ask yourself what's inside the JSON. Just put it into the landing storage and call it the bronze layer if you want. Okay, this is my opinion, of course. After that, silver should produce from this bronze layer the entity that are useful for your scenario, okay, without enriching them, without joining them with other sources, but just the exercise of you have a JSON with 100 fields. This 100 field or nested array should be in actually three entities. So in the silver layer, we should have those three entities, strong typed and cleaned. And even if you want to strip out some fields, do this, okay? After that, for the gold, everything can change because you can have a goal that is an aggregation. You can have a goal that is the result of multiple joins. You can have a goal that, since it's an aggregation and it produces 5 rows, that 5 rows can go through a SQL database. It's not really needed to go to a data lake. But a gold layer should be also a join between many datasets with million or billion of rows. So in that case, that gold dataset should go to the data warehouse or a data lake. This is the really very, very, very condensed reply that I can give you in this follow up. But feel free to reach me out, and this is something that we are thinking about in this period in the company, and I will very happy to discuss with you about it.
Perfect. Where can people reach you if they have more questions? There are more questions in the platform, but we need to to finish and start a new session. So,
Okay,
do you
sure.
have a slide? Maybe?
You can reach me. You can reach me in Pine Tools, maybe.
I'm
Uh,
pretty sure people can should be able to find you. So,
okay, perfect.
if
I'm
anyone has more
connecting now to
questions,
Pine Tools, so I'm there to reply your question.
awesome. Thank you so much again for your session, and thanks everyone for watching.
To you. Thanks so much.